March 20th, 1942, Washington, D.C. Major General Jacob Devers looks at a big problem that has already killed thousands of American soldiers. How can you move 5,000 pounds of bullets and shells from a ship to land when there is no safe land, when German soldiers control every port from Norway to Spain? He writes a worried letter to MIT scientist Vannevar Bush, saying, "We need floating tanks. We need ships that can go to shore. Even with no ports, can your smart people make this happen? The Army. Leaders say it cannot be done. Trucks belong on roads. Boats belong in water. Science rules do not allow both." But a 35-year-old boat designer named Rod Stevens sees the ocean in a different way than the generals he knows how boats move. Through 15-foot-high waves, MIT engineer Frank Spare thinks maybe you can change the air in the tires while the truck is moving, something no one has ever done before. And sailor Dennis Pulliston knows what keeps things floating when huge storms. Try to push them under 3 regular men 38 days, and one wild idea: they are about to show the world that American trucks can float, and that one smart design will decide if D-Day wins or fails terribly: the big wooden table at MIT's Office of Scientific Research and Development holds the weight of America's hardest problems. Vannevar Bush spreads General Devers's letter across the shiny surface and touches the fast handwriting that came. That morning we need floating tanks, ships to shore. No ports. Can your scientists do it? The question hangs in the air like smoke from Bush's pipe, carrying the sadness of the many soldiers who had already drowned. Trying to land on beaches while wearing heavy gear, they could not. Bush understands the math of landing wars better than most generals. Every landing boat costs $10,750, enough to buy 3 Sherman tanks, or give a full team all their gear. But these boats can only leave their load right at the waterline, making soldiers walk across open beaches while German guns fire from bunkers. This old problem had killed more Allied men than the enemy's bullets. How to move 5,000 pounds of needed supplies from ship to safe land when the enemy held every port from Norway to Marseille. It needed minds that were not stuck in Army rules. Bush needed normal men who never learned to think small. Rod Stevens Jr. answered Bush's call on a Tuesday, walking into the MIT office, calm, proud, and ready. Rod Stevens knew how water moved around holes that separated new sailors from champions he could picture in his mind. How water flowed, and how pressure changed with the same skill other men used for building plans. He could see in his thoughts how a well-built boat could cut through 15-foot waves without losing the people or the things it carried. The same math rules that helped boats race fast, like balance floating and water movement, could also help in war with exact results. Frank W. Scharr joined the project from MIT's Mechanical Engineering School, bringing with him drawings that filled every wall of his workroom. The part-time Army officer had spent months trying to solve a problem that seemed small to many engineers but huge for anyone who knew what it was like on a real battlefield. He wanted to control tire air from inside a moving truck. His drawing showed turning seals, air systems, and dashboard buttons. No one had ever made work. Before, in 1942, all Army trucks had one set tire pressure 50 pounds for hard roads, which meant they always got stuck in sand or mud. Speer thought of a system that could change from 50 for hard roads to 12 for soft sand without stopping. The truck. This idea later became a normal feature in all Army trucks. For the next 80 years, Dennis Pulliston finished the strange team. He was a British sailor who had crossed the Atlantic Ocean in boats smaller than Coast Guard ships he had. Learned deeply what keeps boats floating. Even when it seems impossible, Pulliston looked at every design like it meant life or death. He knew that things which work fine in a lab often fail badly in real storms, with salt water shaking engines and 6-foot waves hitting hard. His job was to turn Stevens's boat ideas and Spear's machine ideas into one system that worked perfectly even when enemy guns were firing. Bush gave them a very fast timeline. April 21st, sign the deal with General Motors. April 24th, start building the wooden model teams, working all weekend. April 27th, make a small model for first test. May 30th, finish the first full-size model, ready to try in water, only 38 days from drawings to a real floating truck built on GMC's strong CKW frame, the 2.5-ton Deuce, and a half already trusted by all the American soldiers fighting in Europe. Stevens made the boat bottom with the same care he used in yacht races. He asked for welded steel with a flat bottom and strong ribbed sides so it could stay steady in big waves. The boat was 31 feet long and 8 feet wide, big enough to carry heavy loads, but still safe in the sea. He planned it so it could hold 5,000 pounds of bullets and shells, or 25 soldiers with all their gear, moving them from a big ship to a safe spot on land without needing a dock or a fake harbor. Spear's tire air idea was the most amazing part of the project. His system used buttons and air tubes connected to the tires with special turning seals that kept the air steady even while the wheels spun fast. It took very exact math to make the air move right and still keep the parts strong enough for battle. No one had ever done that before, but Spear's first model worked perfectly: 50 pounds for fast road driving, 25 for rough ground, and 12 for beach sand, all changed by one small lever next to the driver. Pouliston made sure every smart idea worked together. He built the propeller and steering parts so the truck could move 5.5 knots in calm water and still turn safely in waves that would sink normal landing boats. The mix of car engines, boat power, and steering systems needed a lot of brain work, joining sea and land science. The first Army test went as expected. The older officers who judged new machines could not see how a thing that broke all their old rules could help them too. Strange, they said, trucks stay on roads, boats stay in water. The new DUKW got its name from the letters D for 1942, the year it was made, U for amphibious, K for front drive, and W for all-wheel drive. It almost got cancelled before it could show what it could really do. One last test was planned in Provincetown, Cape Cod in December 1942. That final chance would decide if this floating truck could change war forever. 90 Army officers came to watch what might be the truck boat's last test before it got cancelled. Then nature stepped in with a wild storm that turned all their doubt into sudden belief, showing that ideas once called impossible can save lives. When normal thinking fails badly, the weather report for December 3, 1942, said it would be calm with soft winds across Cape Cod Bay, perfect for showing this new half-truck, half-boat to 90 doubtful officers. But instead, a huge storm hit Provincetown like a North Atlantic hurricane, 60 miles an hour. Winds made 15-foot waves crash against the Massachusetts coast, turning a simple test into a real life-or-death trial for the new DUKW machine. The Coast Guard ship rose 75 feet long, made of strong welded steel, and run by sailors who had fought through many storms. Tried hard to stay safe, but the waves looked like they wanted to tear her apart. The crew knew these waters well, every sandbar, every twist of current that could trap a small boat in bad weather. But this storm was stronger than anything they had faced and stronger than their tools could handle. The giant waves pushed the Rose onto a sandbar 200 yards from the beach. Her heavy steel body scraped the sand again and again as each wave lifted and dropped her 6.5-ton weight. Their radio calls for help grew more scared as the cutter started to break apart. Under the beating, no boat her size could last long like that. Normal rescue boats failed again and again. The Coast Guard's special rescue boats made for rough seas had to turn back. Their crews knew if they got closer, they would die too. The 36-foot-long boats had good diesel engines and brave men who had saved hundreds before. But now the waves were too tall and strong. They rose higher than the boat, roofs, and almost flipped them over. Navy rescue boats tried next. These were built to save pilots who crashed at sea. They had flat bottoms and powerful motors that usually worked great in waves. But not today. The wild sea was stronger than their machines. Each time they went near the Rose-Cross waves, hit the side of their boats, turning them sideways, forcing them to go back before they wrecked two small beach rescue. Boats sank right away. Local fishing boats that often handled bad storms, filled with water within minutes. Even the old fishermen who had worked these waters all their lives knew this storm was far too dangerous. The math link between wave size and small boat survival had reached the point where science, not sailor skill, decided who lived and who died. 7 Coast Guard men were stuck on the breaking ship. Rose their radio calls, getting more scared each minute as the boat began to fall apart. Fast, one voice came through the static saying, "She's breaking up fast." The messages reached the test area in Provincetown, where 90 Army officers stood watching every normal rescue plan fail again and again. The trained sailors had the right tools. The military said were good enough for sea rescues, but they could only wait as their ship ripped apart under them. Rod Stevens watched this happen with the same sharp mind that had helped him win many boat races by reading bad weather better than others. The wild storm that stopped normal rescue boats was exactly what he had built the DUKW to handle: 15-foot waves, 60 miles an hour, winds and rough surf that stopped regular boats were the perfect time to prove what his new vehicle could do. "We'll take the DUKW," he told the officers, turning a planned show into a real rescue. His team jumped in fast and ready. A Navy cameraman named Stanley Rosenfeld went with them to film it all. He knew this rescue would either prove or destroy the DUKW project forever. Some engineers who had worked on the math and design were now going to see if their ideas really worked under the most deadly conditions. They packed emergency tools, first aid gear, and radios into the last open space on the 6.5-ton truck boat. The DUKW roared down the Provincetown beach at 50 miles per hour, its 6 big wheels and soft tires gripping sand that other trucks could not handle. Stevens kept going full speed until the very end, then drove straight into the huge waves that had beaten every other rescue boat. Before the DUKW switched from land to sea, without slowing, the car gears stopped, and the boat propeller started working smooth and perfect, just like Spear's smart system was made to do. It moved 5.5 knots through water, rough enough to scare boats 3 times bigger, showing the water design ideas Stevens had learned in years of racing fast boats. The flat bottom floated up over waves instead of cutting through them, and the strong ribbed sides kept it steady and safe, while Pulston's propeller and rudder made sure it could still turn and steer even in those wild seas. The wild waves would have crushed normal small boats, but this showed that smart design and good engineering could win even against impossible weather. The rescue needed the skill of a yacht racer mixed with the quick action of a soldier in battle. Stevens guided the DUKW close to the broken Rose, while both boats went up and down in giant waves that could smash them together at any second heavy. Water poured over both decks, filling the DUKW's cargo area, and testing if its body could stay tight and dry. That one thing meant life or death for both the rescuers and the men they were saving. One by one, Stevens and his crew pulled all 7. Coast Guardsmen inside finishing the rescue just as the Rose finally broke apart. After hours of fighting the sea, the trip back to Provincetown Beach proved that the DUKW could really move on both water and land even with too much weight from the rescued men and extra gear. It still stayed fast and steady while other boats kept fighting to survive when they reached shore. The change from sea to land was smooth. The propeller stopped, and the truck wheels started rolling again, bringing everyone safe to waiting medics and shocked Army officers. The photographer Rosenfeld took pictures of every step, from the moment the DUKW hit the surf to the second it climbed the sand. His photos showed proof that this new truck boat had done what no other rescue boat could in just a few hours. He was on a train to Washington, D.C., carrying the pictures that showed the miracle rescue. The photos would be seen by top Army leaders in less than a day, turning all the old doubts into sudden belief and rush orders for more of the new vehicles that would soon change how beach battles were fought. Rosenfeld's photos reached the Pentagon within 24 hours of the Provincetown rescue on a train speeding through a calm, snowy country. It looked peaceful compared to the wild Cape Cod storm. The pictures told a truth no report or meeting could explain. 7 Coast Guard sailors were alive because one amazing machine had done what every normal rescue boat failed to do. Major General Jacob Devers, the only senior Army leader who had trusted the DUKW plan from the beginning, now had solid proof that his belief in civilian science and new ideas had been 100% right. The pictures moved fast through Army offices, reaching top leaders who had once laughed at the idea of an amphibious truck and called it a waste of money. Every photo showed what really happened in the rescue: the DUKW driving into huge waves, coming close to the sinking Rose, and saving 7 men who would have died without it. These pictures ended all long talks and arguments about what the truck might do. They replaced boring reports with real proof that this new vehicle could save lives even in terrible storms. By October 1942, the Army officially accepted the DUKW and gave big building contracts to General Motors in St. Louis, Missouri. This was a total change in thinking because, before that, the Army had said the DUKW was too tricky and not needed. General Devers's strong support made a big difference. His trust was backed up by real field results and photos no officer could question. The numbers showed how powerful America's factories were during the war. By the end of 1942, the first DUKWs rolled off the new lines that had changed. From making family cars to making war machines, the St. Louis plant that once built Chevrolet cars and Buick coupes now worked only on welding steel bodies and putting in water engines made by 3 clever civilians who built the first working DUKW Don Sitown W. In just 38 days in 1943, building went faster than ever once the Army saw how important the DUKW was. 5,000 were made at General Motors, each one worth $10,750, and carefully built to work on both land and water. Many factory workers were women taking over while men fought overseas. They quickly learned how to put together the hard parts, like Stevens's boat body, Spears's tire air system, and Puliston's propeller setup. The St. Louis plant hit its best speed in 1944, turning out 10,000 DUKWs as the Allies got ready for the biggest sea invasion ever. Each truck came from parts made all over the country: propellers from Michigan, steel bodies from Pennsylvania, and tire systems from Massachusetts. Every DUKW had to pass strict quality checks because a small mistake in war could mean death, not just trouble. By the end of the program, the total number reached 21,137 vehicles, the biggest order of special sea trucks ever. Each one cost about $170,000 today. making the whole program worth over $3.6 billion. The Army knew great ideas needed big spending to win real power. The dukw's first battle came in Sicily during Operation Husky in July 1943. The Allied soldiers faced a big problem that always came with beach landings: how to keep supplies moving from ships in the ocean to army bases on land when the Germans controlled every port normal. Landing boats could drop off cargo on the beach, but then trucks had to come and take those supplies 20 miles inland to where the troops really needed them, like for ammo, medicine, and new parts. The dukws fixed this huge problem. They could drive straight from the ship right to the base without ever stopping at the water's edge. Each one carried about 5,000 pounds of important stuff across beaches. Even while German guns kept firing, the dukws just kept going across rough ground, where normal trucks got stuck. This made supply work faster and much safer before the dukw soldiers had to move cargo many times and risk their lives on open beaches. Now, one vehicle could do it all in one trip. It saved lives and time and worked. Even better than people had guessed, the dukws could go through rough water that stopped other boats, and they kept supplies coming in bad weather when normal landings had to stop. Their 6 big wheels handled soft sand and muddy ground, and the special tire air system let drivers change pressure fast without getting out. This helped them move through any surface. They were also used to carry wounded soldiers back from the front lines to the hospital ships out at sea. So, the same truck that brought ammo could also save lives by taking hurt soldiers to doctors fast. The Germans could not figure out how the Allies kept their supplies moving. They thought the beaches were blocked, but still saw trucks somehow rolling out of the water. Their own reports showed they were confused because they had never seen anything like the dukw. Their war plans had no way to stop something that could drive on both land and sea. By late 1943, the dukw factories were working full-time while the generals planned Operation Overlord, the big invasion of Europe that would decide if the Allies could take back the land from the Nazis. The dukw had proven it could work in Sicily, but Normandy would be the real test to see if Stephen's spear and Puleston's wild idea could help win the biggest war in history. 3 brave men who once built a truck boat in just 38 days would soon see if it could truly change the world. Operation Overlord needed supply planning more exact than any other military mission in history. 2,000 dukws were chosen for the cross-channel attack. Their placement planned with perfect math because success depended on non-stop supplies. 12 companies were sent to Omaha Beach, where German guns and bunkers could wipe out Allied soldiers before they even held ground. 7 more companies went to Utah Beach to help the paratroopers who needed food ammo and medicine right away to stay alive behind enemy lines. Every dukw carried 5,000 pounds of Shell's medical gear and tools that decided if 150,000 Allied troops would live through the first day on German-held soil. These trucks showed how America turned its huge factories into machines of war on both land and water. The St. Louis assembly plants built these very vehicles in spring 1944, each one made stronger from lessons learned in Sicily. Stevens changed the hull so it stayed steady in rough seas, while Spear's tire system now had extra safety controls so it wouldn't fail if hit in battle. Puleston improved his propeller parts with better coatings after salt water from the Mediterranean caused rust and damage. On June 6, 1944, the weather almost stopped the biggest sea invasion ever made. General Eisenhower got reports of huge storms in the English Channel waves, high enough to sink normal landing boats, and winds strong enough to blow paratroopers far from their targets. The seas broke every rule for safe landings, yet waiting meant missing the short calm period when tides were right, giving Germans time to make their coastal defenses too strong to beat. At 6:30 that morning, the first soldiers rushed onto the beaches of Normandy, fighting through giant waves and explosions that tested everything engineers believed was possible for an amphibious attack. From the water's edge to the high bluffs above Omaha Beach, German bunkers filled with guns were ready to destroy any soldier or vehicle that tried to cross the open sand. The first waves of troops caught the enemy by surprise, but were in grave danger unless supplies could reach them faster than the Germans could fight back. The DUKWs came about 30 minutes later, their big engines roaring as they crossed the English Channel, their propellers cutting through the rough waves that would have stopped regular boats. These amphibious trucks carried the bullets, food, and medical gear that decided if the new beachhead could last through those deadly first hours. Each one was a moving lifeline linking the huge transport ships out at sea to the men on shore who were running low on everything they needed to fight. The shift from water to land happened while German guns fired non-stop. DUKWs rolled straight through the surf as explosions burst around them, and machine gun rounds bounced off their steel sides, while clouds of smoke and spray made it almost impossible to see. The drivers had to stay calm and guide their trucks through chaos, their 6 big wheels gripping the soft sand where normal trucks would sink. They pushed forward, carrying boxes of ammo and supplies to the hidden depots just beyond German view. During the first 24 hours of the Normandy invasion, the DUKWs performed far better than anyone had dared to predict. They moved over 3,000 tons of vital cargo, while German artillery tried to wipe out the Allied foothold before it could grow. Old-style landing boats would have needed months to build harbors before moving that much gear, but the DUKWs did it instantly across open beaches. In the week after D-Day, these vehicles proved how crucial they were, bringing supplies to more than 150,000 advancing troops. In those first 90 days, they hauled 15,000 tons of ammunition, fuel food, and spare parts across water and land, keeping the front lines alive and setting new records for how wars would be supplied forever. 340,000 tons of supplies moved through the DUKW system, carrying everything from single bullets to full artillery guns that helped Allied troops push past the beaches into France. These huge numbers showed not only how much gear was moved, but how smart planning and steady supply could beat bigger enemy armies through better logistics. Then nature struck again. From June 19th to the 22nd, a massive storm slammed the Normandy coast with winds as strong as hurricanes. Waves smashed apart Mulberry A, the artificial harbor the Allies had built and trusted for unloading ships. Normal landing boats could not survive those violent seas and had to stop work completely. But the DUKWs kept running. Their strong design, made by Stevens with stable hulls, Spear's tire system that adjusted pressure, and Pouliston's dependable propeller setup all worked perfectly in weather that broke everything else. The trucks rolled over soft, washed-out sand and still reached the big ships waiting offshore, even when the waves were taller than houses. For 4 brutal days, the DUKWs became the only working link between the ships and the fighting troops on land. This hidden crisis proved their real worth. They could keep going when every normal supply plan failed. German commanders had counted on storms to cut off the Allied forces, but the DUKWs ruined that idea. Even when the sea turned wild, the Allies kept getting food, fuel, and ammunition non-stop. Because of that, the soldiers never ran out of bullets or medicine and could keep pushing forward while the enemy's plans fell apart. The trucks showed that in modern war, logistics could win battles just as much as guns could. By the time the German army finally surrendered on May 8, 1945, the DUKW had already changed how wars were fought forever through pure American engineering skill, determination, and courage. The German surrender was signed in a simple schoolhouse in Reims, France, bringing an end to the European war that had raged for 6 long years and taken over 60 million lives. When the final numbers came in, They told a story that amazed every military historian who studied them later. The DUKWs had carried 550,000 tons out of the 15,750,000 tons of Allied supplies that reached the battlefields of Europe. That meant 1 out of every 3 tons that helped win the war, from single bullets to giant Sherman tanks, had been delivered. By the amphibious trucks 3 civilians had designed in just 38 days back in 1942. These numbers meant more than just weight and totals. Every pound the DUKWs delivered replaced older slow systems that needed artificial harbors and several truck transfers across beaches where the enemy could attack. Without them, the Allies would have waited 6 months to build ports strong enough to handle that much cargo, giving the Germans time to make the Atlantic Wall too powerful to break. Rod Stevens's hull design had proved tough enough to cross the stormy English Channel while carrying full loads during battle, showing that ideas from yacht racing could win wars when used with precision. The flat-bottom hull with ribbed sides handled 15-foot waves while staying balanced and steady even under the heaviest cargo, proving a level of control no ordinary landing craft could match. His perfect math for balance and stability saved thousands of soldiers by keeping the trucks from flipping or sinking in rough surf. Frank Spear's tire pressure system became the small change that changed everything about military vehicles forever. His dashboard control let drivers switch from 50 pounds per square inch for roads to 12 for beaches without stopping, giving trucks freedom to go anywhere. Ever since 1945, almost every off-road or military vehicle has used versions of his air control design. Dennis Pulliston's smart mix of propeller and rudder made a marine drive that stayed strong in real combat waves, not just in safe tests. Together, their genius built machines that worked where others failed and helped end the deadliest war in human history. His long experience with sailing in deep waters helped him build engine parts that could handle ocean spray, shaking engines, and the hard hits of big waves while still keeping a steady speed of 5.5 knots, which was needed for quick movement in battle. The engines worked perfectly during fights in the Mediterranean, long trips across the Atlantic, and missions in the Pacific that tested every idea about how strong an amphibious vehicle could be. The 3 main inventions made during that busy spring of 1942 worked together so well that they became stronger than any single part alone. Stevens's hull design made the base for Spear's moving wheel system, and Pulliston's engine setup made both ideas work smoothly on the water where these trucks had to fight. Their success came from civilian minds that didn't follow the military rulebook about what land and sea vehicles should be. During the war's busiest time, factories in St. Louis built 21,137 DUKWs. Each one showed what America could do when it focused on new ideas instead of just making old-style military gear. The program cost $3.66 billion and gave the Allies something money alone couldn't buy: real flexibility that no number of normal landing boats could match, especially during the terrible Normandy storm when every other supply system failed. After Germany surrendered, most DUKWs were quickly scrapped because the military wanted to save money and reduce its forces. The amphibious trucks that had helped win the war were sold off as surplus to builders and rescue workers who used them for jobs on land and water. Many were melted down for their steel, and their clever designs were almost forgotten. The 3 men who made them went back to quiet lives with little credit for their world-changing work. Rod Stevens returned to yacht racing, using what he had learned from the war to build faster, stronger boats that kept winning races year after year. His experience in the America's Cup had already prepared him for the DUKW project, but working on the wartime trucks deepened his understanding of how water moves and how boats stay stable. Lessons that separated winning hulls from ordinary ones. Pulliston wrote books about sailing that shared his knowledge of navigating deep water with hobby sailors, turning lessons learned in combat into tips that made small boats safer for everyone. During the war, he had to master mechanical systems far beyond normal sailing skills, building expertise that helped both military and civilian mariners and became standard reference material for decades. Frank Spear kept inventing new military gadgets, solving problems with smart mechanical engineering, though nothing matched the huge impact of his tire pressure control system. Later, his patents covered suspension systems for vehicles, communications gear, and special tools that improved how soldiers worked, focusing on details other engineers ignored or thought unimportant. When the Korean War began in 1950, dukws went back into action during the Incheon landings, proving again that amphibious trucks could help forces reach beaches without ports. The vehicles that made D-Day a success showed they still mattered in different wars and against new enemies, proving the smart choices made 8 years earlier by 3 men who ignored old rules about military vehicles. Their work left a surprising mark on everyday life, too. Duck tours in cities across America used the same basic dukw design to take tourists through streets and harbors, showing civilian appreciation for the same engineering that had won World War II. Spear's tire pressure system became standard on all military vehicles after 1945, from jeeps to tanks. So his 38-day invention shaped mobility for future generations. The mechanical ideas he developed under pressure became the foundation for vehicles that could work in deserts, snow, and ice. The bigger lesson of their achievement went beyond the battlefield. 3 men ignored experts, challenged old ideas, and made the impossible real through civilian thinking applied to military problems. Their success showed that breakthrough innovations often come from outsiders who are willing to try what professionals say can't work, creating solutions that were essential in practice even if they seemed impossible in theory.